In this module, we will consider the elastic properties of solids. We have treated objects as if they were rigid, but realistic objects deform to some extent when forces act upon them. The kind of deformation that occurs depends on how the forces are exerted on the object. In general, the measure of the force exerted on an object is referred to as the stress, and the measure of the deformation in an object caused by the stress is referred to as the strain. If the stresses applied to an object are not too great, then the relationship between the stress and the resulting strain will be linear. The ratio of the stress to the strain in this linear regime is a characteristic of a given material called the elastic modulus. For example, Young's modulus applies to the case of tensile or compressive loads on an object. The object stretches under tension and shortens when compressed. In this case, the elastic modulus is called Young's modulus. The stress is a measure of the force per unit area. That is, the force divided by the area across which it is being applied. The strain is the ratio of the change in length to the length of the object. Note that the stress is felt along the entire length of the object, so the longer the object is, the more deformation there will be in the object. If we look at a plot of the stress versus strain, we notice that for small stresses, we have this linear relationship between stress and strain. However, beyond a certain extent, if enough stress is applied, the object will yield. That is, it will deform irreversibly. Something inside the object will break, in essence, and will never be able to revert back to its original form. This doesn't mean that we cannot still support more stress within the object, and it will still extend further, but it will typically not be under a linear relationship after this point. There is a maximum stress that an object can handle, beyond which it will start to visibly stretch, and this stretching is often referred to as necking, and eventually, once the object starts to stretch and pull apart, it will eventually fully fracture. The shear modulus applies to the case of opposing forces applied parallel to opposite faces of an object. In this case, notice that the force F is applied to the top face of the object and pulls to the right, whereas the second force, minus F, pulls to the left on the bottom face of the object, causing the top face to shear towards the right relative to the bottom face of the object. For the shear modulus, the stress is defined again as a force per unit area. But in this case, it is the area which is along which the force is being applied. The strain is a measure of the change in the horizontal position of the upper surface relative to the height difference between the surfaces on which the opposing forces act. The bulk modulus is a measure of an object's resistance to uniform compression. In this case, the bulk modulus is a measure of the change in the force per unit area divided by the change in the volume divided by the original volume. Notice the minus sign because as we apply a force, the volume is actually going to get smaller. The stress again is the force per unit area, and the strain is the relative change in the volume. For the bulk modulus, it is typical to express the stress in terms of the change in the pressure acting on the object. This is because most typically when we deal with the bulk modulus, we are in a situation in which the object is inside some medium which will apply a uniform compression to the object.